Students, now we will see the problem. First problem, a jet plane starts from rest. That means a jet plane starts from rest means the initial velocity is 0 and it moves with an acceleration of 3 meter per second. So the acceleration is a is equal to 3 meter per second and it makes a run for a time. So the time taken for the running is 35 seconds before taking off. That means a jet plane is moving with the initial start from rest. It starts to move with the 35 seconds. How much distance it is covered? That is the question. So a jet plane starts from rest with an acceleration of 3 meter per second and makes a run for 35 seconds before taking off. So what is the length of the runway, minimum length of the runway, and what is the velocity of the jet plane? So the given data are u is equal to 0 and a is equal to 3 meter per second and t is equal to 35 seconds. So first you read the question carefully and find the given data. Then you have to analyze that. What is the calculation? We have to find the s and v. So now you see the three equations of motion. V is equal to u plus at and v square minus u square is equal to 2as and s is equal to ut plus cos at square. You substitute all the given data in these equations. We are able to arrive that u at. We know that. So we are able to find the velocity. U at. So we know all these values. So we can able to find the displacement. So that is they are asking that. What is the length and velocity? So s is equal to ut plus half at square. Substitute u is equal to 0, half, a value 3 and t value 35. You find the length 1837.5 meter. Also for the velocity, v is equal to u plus at. Substitute the u value, a value and t value, arrive the velocity. The students may ask one question. Sir, why we cannot use the v square minus u square is equal to 2as? Yes, you can do that, but the time factor is very, very important. Here it is in the given data, they are given the time. So we have to use these two equations. Let us see that. So this is for writing the classwork purpose. I will show this problem very slowly. So this is a question and the given data. So this is a solution. Yes, students. Now we are going to see the next problem. On a foggy day, two drivers spot each other when they are just 80 meters apart. That means the two car drivers watch as they are not down the opposite cars. The distance between the two cars is 80 meters. They are traveling with the 72 km per hour and 60 km per hour respectively. That means the one car is come with the 72 km per hour speed and the second car is in the opposite side. It comes with the 60 km per hour speed. The both of them applied a brakes. So after seeing both of them are in the opposite direction, so they apply brakes. The retards their cars. Retarding means slow down their cars at the rate of the brake acceleration. Deceleration value is 5 meter per second squared. So they are spot each other at 80 meters apart. They are coming with the velocity 72 and 60 km per hour. After seeing that, they are applying the brake. Both of them applying the same amount of deceleration. The deceleration value is 5 meter per second squared. Determine whether they will collide or not. That's all. So very interesting problem. So two cars coming opposite directions. They are giving the velocity of the each cars and they are giving the distance between these two cars. After that they are applying the brake with the same acceleration, that is the same deceleration value, whether they will collide or not. So imagine the problem very clearly. First you write the given data. So what is the initial velocity of the first car? 72 km per hour. What is the initial velocity in meter per second? So how you can convert? So 1 kilometer is equal to 1000 meters. So into 1000. Then 1 hour you have to convert into seconds. So 60 into 60. By solving these things, we get an answer 20 meter per second. So always you should do the problem in SI units, meters only. Then what is the final velocity? 0. Sir, how we can determine that final velocity is 0? Because we have to avert the collision, stop the collision. That means after applying the brake, the car will come to rest. So the initial velocity is 72 km and the final velocity is 0 by applying the deceleration value minus 5 meter per second. So it is acceleration. It is reduce the speed. So we can put minus here. What is the displacement? Very simple. v square minus u square is equal to 2as. This s1 is a first car distance covered. So final velocity is 0, initial velocity is 20, then acceleration is minus pi. Why we will put minus? Because we are reduce the speed, deceleration is given, so we have to put minus sign s1. So by solving this equation we get the distance 40 meter. That means out of 80 meter, after applying the brake, the first car which is coming with the 72 km per hour, it covers a distance of 40 meter. So similarly we can derive the expressions for second car. So now you see that for the second car it moves with the velocity 60 km per hour. Convert the 60 km per hour into meter per second. Multiply by 1000 and divided by 60 into 60. We get an initial velocity in meter per second as 50 divided by 3. What is the final velocity? 0. The same deceleration minus pi meter per second squared. Dear students, very clear. The car A is coming with the acceleration, that is it will move with the velocity 72 km per hour, and the second car is moving with the 60 km per hour. So both are moving in this direction, both are applying the same acceleration minus 5 meter per second square. So in previous page we determined that the distance covered by the first car is 40 meter. Now we are going to determine that what is the distance covered by the second car. By using the same formula, v square is equal to u square plus 2a s2, substituting this u value and a value and everything, we get an s2 value as 250 by 9. So the s2, the distance covered by the second car is 27.78 meter. So the first car covers the distance of 40 meter, second car covers the distance of 27.78 meter. What is the total distance between the two cars? Before applying the brake, it is 80 meter. After applying the brake, the first car moves the distance of 40 meter and the second car moves the distance of 27.78 meter. So it does not cover 80 meter. If you add up these two things, we get only 67.78 meter. That means successfully the two cars does not collide. The accident is avoided. So clear students, by using the equations of motion, we are going to solve these types of problems very clearly. Now, it is a motion under gravity. Motion under gravity means in the absence of air, the air resistance is absent. That means we are avoided that there is no air is present, means all the bodies fall with the same acceleration because the earth will pull in the downward direction with the acceleration due to gravity value g is equal to 9.8 meter per second square. So if there is no absence, you can see the famous experiment, feather and coin experiments. If in the vacuum space, if the feather and coin are dropped down in the same height from the same height, if both will reach the ground at the same distance, same time. So that means there is a fall of gravity is same. So if you have any doubt, you go through the feather and coin experiments one more time. In the feather and coin experiments, the absence of air, both the coin and feather will reach the ground at the same time. That means the acceleration is same. That acceleration value is 9.8 meter per second. That fall is called as a free fall. So you can write the equation of motion for free falling body also. Very simple. Instead of A in the previous equation, 3 equations, substitute G. That's all. So S is equal to ut plus half at squared. Instead of A, you substitute G. Here V is equal to u plus at. Here instead of A, G. And V square minus u square is equal to 2as. Instead of A, you have to substitute G, means that the equations of motion will become a free falling body equations of motion. When a body is thrown vertically upwards, the velocity decreases and the value of g is taken as a negative. So when the body is thrown upwards, what will happen? The velocity decreases and reaches the maximum point, the velocity is 0. So we have to take the g value is minus because it will against the acceleration is always downwards. So the body is moving opposite direction. So we have to take the g as a negative. Here the g as a, if it is comes down, it is a g as a positive. So dear students, here we are seeing the problems very clearly. So for writing the classwork purpose, I will show the problem very slowly. So this is a question. Here it is the answer. Then the answer continuation. This is a third one. And then only you have to write this one. For understanding purpose only the diagram is drawn here. You no need to draw the diagram in examination. If you want, you can try that. Then finally we will see that motion under gravity. So this is the explanation. So the equation of motion for motion under gravity. Thank you, students.